what do you remember about covalent bonding?
Well, the covalent bond is a type of chemical bond formed by the mutual sharing of valence electrons between the combining atoms of the same or different elements.
Go on.
I also remember that a covalent bond generally forms between nonmetals when the difference between their electronegativities is too small for an electron transfer to occur in order to form ions.
Exactly. That's what separates a covalent bond from an ionic bond.
But teacher, from what I recall, ionic compounds consist of oppositely charged ions held together by electrostatic forces, whereas covalent compounds generally consist of molecules. So, what holds the atoms together in a covalent bond?
Well, even in a covalent bond, the atoms are held together by the electrostatic force of attraction.
Really? How?
In covalent compounds, electrons are shared in pairs. Due to its negative charge, the electron pair will attract the positively charged nuclei of the bonded atoms.
Oh, so this electrostatic attraction between the positively charged nuclei of the bonded atoms and the negatively charged electron pair holds the atoms together in a molecule.
Correct, but do remember that the electron pair must lie between the nuclei for the attraction to outweigh the repulsion between the nuclei.
I see.
Also, remember that once the atoms are bonded covalently to other atoms, the bonded atoms have a lower total energy than that of widely separated atoms.
That must mean that in covalent compounds, the bonded atoms gain stability by sharing their valence electrons.
Indeed, for covalent bonds, atoms tend to share their electrons with each other so that they completely fill their valence shells and attain the octet state.
Ah, right. I recall that when atoms attain the octet state, they have the same electronic configuration as that of their nearest noble gas.
Correct, but there are also some exceptions to this octet rule.
Yep, the hydrogen molecule is an example of this because hydrogen can have a maximum of 2 electrons in its valence shell, right?
Correct. Since you brought that up, let's draw the dot and cross diagram for a hydrogen molecule, which is one of the simplest covalent compounds.
Sure, I've got this. A hydrogen molecule is made up of 2 hydrogen atoms, each with 1 valence electron in a 1s orbital. Both hydrogen atoms share those 2 electrons in a covalent bond, and each acquires a helium-like electron configuration.
Nicely explained. To add to that, a shared pair of electrons is called a single covalent bond or a bond pair, and it's represented by a single solid line between the atoms like this. Such diagrams are called displayed formulae, and they make it much easier to understand covalent bonding.
Understood.
Good. Next, let's look at a chlorine molecule. When chlorine atoms combine, not all the electrons are used in bonding. Each atom in a chlorine molecule has 3 pairs of electrons that aren't used in bonding and are called lone pairs.
So each chlorine atom has 3 lone pairs of electrons and shares 1 bonding pair of electrons.
Correct. Anyway, here's some more examples of dot and cross diagrams for covalently bonded molecules. These compounds contain a centrally placed atom to which other atoms are covalently bonded. We will discuss these molecules some more in our upcoming lessons, but one thing you must note from these diagrams is that the atoms like hydrogen form only one covalent bond with other atoms.
Got it.
However, atoms like carbon, oxygen, and nitrogen can simultaneously bond to more than one atom. The number of such bonds is also the valency of that atom.
Oh, so this is why the valences of carbon, nitrogen, and oxygen are 4, 3, and 2 respectively, right?
Correct. Now that we've discussed single covalent bonds, let's talk about multiple covalent bonds next.
Are you talking about double and triple covalent bonds? I recall that oxygen molecules form double covalent bonds.
Yep. In order to form an oxygen molecule, each oxygen atom has to gain 2 electrons to complete its outer shell. So, in this case, two pairs of electrons are shared and two covalent bonds are formed. Take a look.
Finding this helpful? We have additional learning resources to offer. For Cambridge IGCSE and AS A-level subjects.
So, the double covalent bond in the molecules is represented by a double line between the bonded atoms.
Yes. Here are the dot and cross diagrams for carbon dioxide and ethene, both of which have double covalent bonds.
Got it.
Now, keep in mind that atoms can also bond together by sharing three pairs of electrons, which we call a triple covalent bond.
I remember that. Nitrogen molecules have triple covalent bonds, right?
Correct.
So, in order to form a nitrogen molecule, each nitrogen atom needs to gain 3 electrons to complete its valence shell. So, 3 pairs of electrons are shared and 3 covalent bonds are formed between them.
Exactly. Here's the dot and cross diagrams of some more molecules containing triple bonds.
So the dot and cross diagrams for covalent compounds aren't that difficult to get after all. We just need to make sure that each bonded atom gets the electronic configuration of its nearby noble gas.
Indeed. But let me remind you that there are some cases in which the electrons around a central atom may not have a noble gas configuration.
Really?
Yep. For example, boron trifluoride only has 6 electrons around the boron atom. So we say that the boron atom is electron deficient.
Wow, that's really interesting.
But on the other hand, there are some covalent compounds of elements in period 3 that can sometimes expand their octet state.
You mean they can have more than 8 electrons in their valence shell?
Exactly. For example, sulfur hexafluoride has 12 electrons around the central sulfur atom. So we say that the sulfur atom has an expanded octet.
That's so cool. But how are they able to accommodate more than 8 electrons in their valence shell?
Well, for this level, the in-depth details of why they are able to accommodate more than 8 electrons isn't required, and it's really quite complicated to explain. You just need to understand that, generally, some elements in period 3 can expand their octet and thus have more than 8 electrons in their outer shell. It is a type of bond which is formed when only one atom provides both the electrons needed for a covalent bond.
So in a normal covalent bond, the bonding atoms contribute at least 1 electron each to the shared pair of electrons. While in a coordinate covalent bond, both the shared electrons are contributed by just one of the bonded atoms.
Correct. That's the main difference between a normal covalent bond and a coordinate covalent bond.
So what are the conditions required for the formation of the coordinate bond?
For the formation of a coordinate bond, we need one atom that has a lone pair of electrons and a second atom that has an unfilled orbital to accept the lone pair, in other words, an electron deficient compound.
Can you give me an example, teacher?
Sure. An example of a coordinate bond is the ammonium ion, NH4+, formed when ammonia combines with a hydrogen ion, H+. As you can see here, the hydrogen ion is an electron-deficient species with space for 2 electrons in its shell. The nitrogen atom in the ammonia has a lone pair of electrons which is used in the bond formation.
Oh, so the hydrogen ion acts as an acceptor ion, while the nitrogen atom in the ammonia acts as a donor atom.
Correct.
And by the way, how is the coordinate bond represented?
In a displayed formula, a coordinate bond is represented by an arrow which is pointed away from the lone pair that forms the bond.
So does that mean that the head of the arrow is pointed towards the acceptor atom or ion from the donor?
Yes, exactly. Apart from that, another molecule that has coordinate bonds is aluminum chloride. Aluminum chloride is an electron-deficient species which needs 2 more electrons to complete the outer shell of the aluminum atom. When it is heated, 2 two molecules of AlCl3 combine to form a molecule with the formula Al2Cl6. It exists as a dimer where lone pairs of electrons on two of the chlorine atoms form coordinate bonds with the aluminum atoms.
Oh, that's so cool. So teacher, what kind of properties do these coordinate bonds show?
Well, although coordinate bonds can be considered a special case for covalent bonds, they basically show the same properties as that of covalent bonds.
Register now for free.